Hello everyone. So welcome back to the Applied Attack Surface Analysis and Reduction course. So let's start with the section 1. So in this particular section we are going to explore the core concept, the basic concept, or you can say the fundamentals of the attack surface. So not only we are going to learn the attack surface, but also what is attack surface analysis and reduction. So basically we'll start with the W world. So I personally call it a W world, which means we are going to explore all the W questions, which is what, why, when, how, and everything. So basically we'll start with the what is the attack surface, what are the real world examples, and what are the enterprise level or organization level example, what is attack surface versus attack surface analysis and reduction process, why this is particularly needed, what is the necessity for that, and once implemented successfully, what all benefits or significance it can have on the organization. And lastly, we are also going to cover all the processes that are involved in the attack surface analysis and reduction, and what all other use cases we can derive from this concept. And when I particularly mention about the concepts, we are going to dive into where the attack surface can be particularly used within the vulnerability management, threat intel, and some other divisions. So let's start. Hello all. So this is video 1.1 in section 1. So let's start with the attack surface introduction. So we'll slowly start with the basic fundamentals of the attack surface. So the formula which is appearing on your screen is attack surface is equal to total entry points plus unpatched vulnerabilities plus misconfiguration plus user risk factor. So let's break it down this formula. So basically what I'm trying to convey is attack surface can combine multiple factors. Now the total entry points are the points from where the data can enter or exit in your organization, right? So it can be your email server, it can be your web application, it can be your networking services through which the data can be, sent and received. So these are the total entry points basically. Now these total entry points are facilitated by some sort of assets, as I mentioned, email servers or web servers, database, network services and all. Now, all these assets and services might have vulnerabilities, and some of these vulnerabilities could be fixed, but some of these vulnerabilities can also be not fixed. So those are the unpatched vulnerabilities. Now, unpatched vulnerabilities are nothing but just a weakness through which malicious actor or an attacker can exploit this weakness in order to leverage that to send or receive data, right? So these are the unpatched vulnerabilities. Now, if there are no vulnerabilities, it can also be happen that they might have some misconfigurations. So misconfigurations are basically improper setup of those assets, improper configurations, improper security settings of those assets, due to which it exposes data or due to which it exposes to the world, and that is something which malicious actor would try to leverage and try to exfiltrate data. So when I say exfiltrate data, which means they can try to steal the data. And the user risk factor. Now, user risk factor can involve phishing. For example, you have all the things in place and tight security, but if a phishing email comes in and then someone clicks on the phishing email, and then that user can be compromised, their email account can be compromised. So that is one thing. Now, user risk factor does not only include phishing, but there are so many different types of user risk factor, which we'll also cover in the later part of the course. So another example could be user behavior and entity analysis. So for example, you might have malicious actor within your company who has wrong intention, and they are legitimately leaking the data, they are legitimately stealing the data without anyone's knowing. So that can also be considered in the user risk factor. So that is how the attack surface can be formulated. So attack surface is equal to total entry points through which data can come and go, plus weaknesses in the assets that can be called as vulnerabilities or misconfiguration, and the user risk factor. So basically, in the simple words, the entry points are nothing but the potential areas through an intruder can come and go or can fetch data. And this concept has just evolved beyond the technical aspects. So previously, it was all around the technical aspects and how companies can be breached technically through phishing and some technical vulnerabilities and some other stuff. But now it's not just technical aspect. Because you might have heard about the red teamers or penetration testers or even malicious threat actors, they break into the organization with even physical elements. So they come into your organization, bypassing security cameras, bypassing security gates, impersonating some employee's ID badge or their identity, and they come into your organization. They roam around, they find the weaknesses, what all they can easily access, and they try to steal the data, right? So attack surface is not only the technical expert, but you should also consider the physical elements into it. And now what all physical elements will cover into this, that is also coming in the later part of the video. So we will go through one large retail company organization your case study, and then we will derive what all physical attack surface can be there apart from the technical aspects. So if the organization is large, they will have larger attack surface, which also means that the attackers will have more opportunities to break into the organization. You might have heard about the bug bounty hunters targeting, Facebook and Google legitimately in order to find weaknesses and then submit them so that companies can give them a reward. Now you might think that Facebook, Google, and other big companies, they are there in the market from so many years, and why they don't have foolproof security, because their attack surface is larger, because the organization is larger. They have plenty of thousands of servers, and maybe many of them are managed, some of them are unmanaged, some of them are unknown. So that's how malicious actors, they try to find assets which are not something which is a central point of interest for those organizations. So people might forget about those assets, they are abandoned on the internet, or they might have some weak configurations, or they were not added into the standard operating procedures of pen testing vulnerabilities, and that's how the risk remains there. And these are the particular things that attackers or bug bounty hunters, penetration testers will try to exploit in order to go get into that organization. So in summary, if you have a large company, your attack surface will be definitely larger. And the attack surface is constantly evolving. Previously, we were not considering physical element in the attack surface. Also, previously, we were not considering like cloud security. So cloud security is there. It's not something new. But because of the complexity of the cloud and the complexity in the entire general IT landscape, the attack surface is also very complex, and it is evolving day by day. I mean, if you ask me like 10 years, 15 years before, SOC and SIEM, they are not threat intelligence. These are not some of the domains which were very common. So yes, they were there. Companies were, normal companies were using. So yes, they were there, and big companies were using, but it was not widely adopted practices and all. Now, because the IT landscape is constantly evolving, there are cloud technologies, containers, OT security, IoT, SCADA, mainframe devices, and other stuff. That's why attack surface is also increasing, and that is why we need to pick up the pace and try to identify all of our different types of assets and what can be considered in our standard operating procedure in order to reduce the risk, right? So this is why we have to continuously review the attack surface. And this is not the only reason that there is a IT landscape complexity, but also in many companies or in many big companies, there are lack of standardization. There are no standard operating procedures when it comes to buying a new domain for the web application, or buying a new IP range, or decommissioning assets, or launching a business code services through some servers or database or something. And because they might have a freedom within the company for the developers, and they develop anything and everything, and there are no standardization, there are no secure coding practices and all, and they put into the production and it goes live, and company has no visibility that when this website or that application or the core services went live. And that is why when they didn't have any visibility, they have not added them into the standard security strategies like vulnerability management, SOC, threat intelligence and all. And because of that, we have to continuously and proactively check about all of our assets for the company, because we might find something new which we are unknown to, and that is why it's a continuous process. So let's talk about the real world example, because I talk a lot about the technical aspect, but let's start with very basic, which is let's take an example of house burglary. So I'll give you 2 minutes, and can you think of all the different entry points, or you can say attack surface for a thief to break into the house? Okay, so let's look into the example. And these are not something which is different. Like this is something you already know. So front door, of course. back door, windows, garage door, pad door, ventilation system, roof access, basement door, windows, balcony doors. Now, depending upon house, this can also vary, but these are some of the common entry points to for a thief to break into the house, right? So this is something which I would call it an attack surface. Now, similarly, let's take an example of an enterprise or the organization. So there are for one large organization, there could be so many different types of attack surface, including people, process, technology, and physical element, which again we will dwell into very detailed, which is something we will definitely go into the very detail in the later part of the course. So the common attack surface for the large organization would be web applications, email system, end user devices. So basically, email system is your Outlook or Gmail or some other email services that you are using. End user devices are laptop, corporate laptop, desktop, corporate mobile phones, and some other devices, networking equipments, cloud storage services, AWS, Azure, GCP, any other cloud you could be using. It could be your private cloud, public cloud, or hybrid data centers, third-party softwares and services. Which means if my company is using services from the third party, so what particular data that third party stores or processes or manage, and is it something that is third party's responsibility, or is it something that is our company's responsibility when it comes to security? So wireless networks, employee behavior, as we discussed earlier. So these are definitely some of the larger attack surface for a larger organization. Of course, we haven't considered the physical element here, but physical element could be also there, like impersonating employees through the ID badge, impersonating employees through emails, then social engineering security guards to let you in into the organization, and these are something which you guys already know. So I was just trying to give the enterprise level attack surface or the entry points, and how we know we can explain the attack surface to laymen by giving an thief and house burglary example. So APIs and much more. And obviously, if the organization is larger, it would be very complex and very large attack surface. So we talk a lot about the attack surface, and when we talk about the attack surface is associated with assets, right? So we haven't talked anything about the assets. So assets, you already know there are different types of assets: end user, email system, servers, data center, and everything. But on a very high level, let's try to categorize the asset. Now, when it comes to asset categorization, there are so many standard practices, there are so many defined definitions and methodologies out there. But in this particular course, I'm going to define the assets into 4 different parts, and that is specifically for the attack surface analysis and detection course. So the first one is a known asset, which means these are the assets which a company should know, and company is knowing already, and company is already managing. And when I say manage, which means company has already added these assets into the inventory. They know who are the asset owners, they know the criticality of the asset, they know what is the purpose of the asset, when the asset was created, when asset was last modified, and what is the asset location and everything. And the company has already added this asset into the monitoring system, this asset into the vulnerability management and vulnerability scanners, and regular pen tests or red team activities against these assets are being carried. So these are something which is known as, which means company definitely knows about this asset. Now, the second one is unknown assets, which means these are company assets, but for some reason, companies do not aware about these assets. And there could be a variety of reasons. So let's say a particular DevOps team within the large organization, they had an urgent requirement, they quickly created a web application, they quickly requested the web server and the application server to the infra team. They have allocated them and they have put the application live. Now, because it was a quick requirement, and if the company does not have a standard operating procedures, they don't have a proper policies in order to go and get the permissions and inventory first, and then build something and then put it into production, then DevOps team might just fulfill the task. And when it goes on the internet, because the things have not, or the assets have not been inventoried, they have not been put into the monitoring system, there was no proper vulnerability management and pen testing was done on these assets, it becomes unknown assets. And when I say unknown asset, which means that particular team might be knowing about that asset, but the security team within the company does not know, or the whole company doesn't know about that asset. So that particular team is a DevOps team anyway. They don't deal into the security 24 by 7. So when I say unknown asset, which means the security team does not know anything about those assets when they were put into the live, for what purpose, who owns this, where is the location, and everything. So these are something which should be managed by the company, but for some reason, and for all these reasons which I have explained, that they are not aware of these assets. And there are vendor assets, which means, let's say, some companies are using third-party cloud services, some companies are using third-party vulnerability management services or SOC services or something else. So now those vendors are also managing your data, and they are managing your data through assets. Now, whether those assets are located at your place, or whether it's a cloud solution or a SaaS solution, or what is the criticality of those data, whether that is something should be managed by them or whether that is something should be managed by your company. And that these are all something which can be taken care by the procurement team or the vendor evaluation criteria and business criticality of the data applications and everything. But also this is something which we should also take into the consideration when it comes to the vendor assets and subsidiary asset. A large company would have multiple subsidiaries. So for example, if we talk about the Facebook, then now the company is Meta. Right now they have one product which is Facebook, another product which is Instagram, another product which is WhatsApp. So they have multiple subsidiaries, and subsidiaries would have their own subsidiaries, right? And again, the question comes, when it comes to the responsibilities, the management should decide who owns what and who should be managing what. And is it something which is already mentioned within the written confirmation throughout all the subsidiaries? Is it something which is already added into our information security policies? Are there any RACI metric, like who would be managing what and who should be responsible for the overall security? Whether do they have a dedicated security or not? These are all the things that a management should decide. So in high level, like known assets, unknown assets, vendor assets, and subsidiary assets. Now your attack surface becomes, so now your attack surface is a combination of known, unknown vendor assets and subsidiary assets.